Welcome to Subject Basics, where you can learn the basics covered in various academic subjects, as well as the basics on various topics from career to business that impact your daily life. Remember, in order to understand any complex subject, you must first learn the basics. Chemistry, the field of science dedicated to the study of matter. In chemistry, we get to know matter very well. What matter is, sources of matter, how matter behaves or reacts. So what exactly is matter? It's the stuff around you, around me, around all of us. But to be specific, matter is anything that has mass and takes up space. That's a lot of things. The air you breathe, the water we drink, the ground everyone walks on, and more. If that isn't clear enough for you, quite simply, matter makes up the objects and things you can smell and touch, and there's even matter so tiny that you can't see it. Hello, the air we breathe every day is transparent, and that's assuming you live in an area free of smog and other air pollution. The air, of course, is composed of matter. Lots of matter that is so tiny it's thought of as invisible can actually be viewed with special equipment used by scientists. The atom. The atom is the smallest unit of matter for a given element. The element? An element is a pure substance that is made from a single type of atom. All known elements, along with important characteristics of each element, are displayed on the periodic table. I have a link to a video on the basics of the periodic table in the description box below. But again, before you dive into that, you'll want to watch the basics covered in this video as well as part 2 to this video. Now, an atom is composed primarily of 3 particles, frequently referred to as subatomic particles. These subatomic particles are electrons, protons, and neutrons. Now, with the atom in mind, let's work our way from the outside in. Electrons are particles with a negative charge and are located in shells, also referred to as energy levels, that surround the nucleus of an atom. Electrons are important for the bonding of individual atoms together. Atoms bond all the time and make molecules with unique chemical and physical properties that make up the matter in our universe. Proton. Protons are particles with a positive charge and are located in the nucleus, also known as the center of the atom. Now, the positive charge of the protons in the nucleus of an atom attracts the negatively charged electrons that surround the atom. Now, it's important to keep in mind that when the shell or outer energy level of an atom is further away from the nucleus, the proton's influence on the electrons becomes weaker, which allows an atom's outer electrons to participate in an atomic bond with another atom's outer electrons, and these outer electrons are called valence electrons. Neutrons are particles that have a neutral charge and are located in the nucleus of the atom. A neutral charge simply means no net charge. So a neutron is neither positive or negative. All elements have atoms with neutrons except for one. A normal hydrogen atom does not have any neutrons in its tiny nucleus. Now, you heard me use the word charge, and you may also be familiar with the word charge if you've taken physics. Now, charge here refers to an electric charge, and a charge is a physical property that causes matter to experience a force within an electromagnetic field. That force is either to attract or repel. Charge affects an atom to the extent that it either loses or gains an electron. Now, as far as an electromagnetic field is concerned, electromagnetic fields are present in our physical environment, and it's a physical field produced by moving electrically charged objects. Scientists can use special equipment to detect an electromagnetic field. Again, here is an image of the atom with the electrons sitting on the shells that surround the atom's nucleus. Now you may be asking yourself, if all elements are made up of atoms, and all atoms are made up of protons, electrons, and neutrons, then what separates one element from another? Well, each element has a unique combination of protons and electrons that makes up the atom. And certain atoms are surrounded by different numbers of shells or energy levels than others. Now, it's this difference in quantity in terms of protons that is most important in separating one element's identity on the periodic table from another. Now, we talked about differences in elements, that one neutral atom or element has a certain amount of electrons and protons, and another element may have a certain amount of electrons and protons that make it that element. So remember, unless noted as otherwise, an atom of a specific element has an equal amount of electrons and protons and is considered to have no overall or additional charge. And again, this is referred to as a neutral atom when there's no overall or additional charge because there's an equal amount of electrons and protons. The overall charge of an atom only changes when the proton and electron count of that atom are no longer equal through the loss or gain of an electron. The atom's overall charge becomes positive if a neutral atom loses an electron, so the proton count then outnumbers the electron count, and the charge becomes negative if the atom accepts electrons, given that the electron count will now outnumber the proton count. That's it for now. Be sure to click on part 2 of this video. I have the link below where I'll introduce more information and more basics that are important to know about this topic.